All right, let's talk NEET. You know that every single mark is a battle, right? Well, today we're drawing up the ultimate game plan for a chapter that is an absolute goldmine for points, but it can be super tricky if you're not ready for it. I'm talking about gravitation. So let's get into it and build your strategy to completely own this chapter. So why are we zooming in on this one chapter so much? It's simple. Gravitation consistently gives you a predictable 8 to 12 marks on your exam. Think about that. That's 2, sometimes even 3 questions that are basically yours for the taking, if you have the right strategy. This isn't just another chapter, it's a high-value target for getting a top score. Okay, so the multi-million-dollar question is, how do we lock in those marks? That's exactly what this explainer is all about. We're going to build your personal playbook, covering what to study, what traps you've got to avoid, and exactly how to solve real exam questions like an absolute pro. Every battle needs a strategy, and ours begins right here, identifying the most important concepts on the battlefield. These are your high-yield targets, the areas where NEET examiners just love to ask questions. Mastering these, well, it's completely not negotiable. First up on our list, Kepler's laws. You can think of these as the rules of the road for planets and satellites. Now, while all 3 laws are important, that third law is pure gold for NEET. The key thing you gotta remember is this simple but powerful relationship. The square of the orbital period is directly proportional to the cube of its orbital radius. Seriously, burn t squared is proportional to r cubed right into your memory. Next, let's talk about good ol' G. But here's the catch that trips up so many students. G is not a constant 9.8 everywhere. That's the trap. Its value actually changes as you go up in altitude or as you go down into the Earth. NEET questions will absolutely test your understanding of these variations. So, knowing the specific formulas for both height and depth is critical. Okay, let's talk speed. There are 2 important speeds here. There's the speed you need to stay in orbit, that's orbital velocity. And then there's the speed you need to break free from gravity completely, that's escape velocity. And here's the best part. There's a really simple link between them. The escape velocity is just the orbital velocity multiplied by the square root of 2. That's a golden relationship you just can't afford to forget. And of course, we've got to round out our high-yield list with the fundamentals, right? We're talking about Newton's universal law, the concepts of gravitational potential and energy, and the nitty-gritty of satellite motion, including their time periods and total energy. You cover these, and trust me, you've secured the core of the entire chapter. All right, so knowing the concepts is half the battle. The other half is knowing the enemy's tactics. Let's pivot to defense now and learn how to dodge those score-killing mistakes that students fall for year after year. This is just as important. Here it is. This is one of the biggest pitfalls. You know G changes with height and depth, but do you know that the formulas are fundamentally different? Applying the wrong one is an incredibly common mistake, and it's a totally avoidable error in the exam hall. So here's the crucial difference. For height, notice that the r plus h term is in the denominator and it's squared. That means gravity weakens really fast as you go up. It's an inverse square relationship. But for depth, look at the formula. It's a simple linear relationship. See the d right there in the numerator? No squares. 2 different situations, 2 completely different mathematical rules. Getting this right is a guaranteed mark. And here's another classic trap. Gravitational potential and gravitational field. They sound similar, don't they? But in physics, they are worlds apart. One's a scalar, the other's a vector. Confusing them can send your calculations and your marks off in a completely wrong direction. Let's break it down really simply. Potential is a scalar. It's just a number, it has no direction, and it's always negative. Notice in its formula, it's inversely proportional to r. The field, however, is a vector. Direction is everything, and its formula is inverse to r squared. This distinction, it's absolutely key. So now that we know what to study and what to avoid, let's put it all together into a winning game plan. This is your actionable roadmap to not just understand gravitation, but to actually master it for NEET. This is how we turn that knowledge into points on the board. Here it is, simple and devastatingly effective. Step 1, start with the NCERT textbook. That is your foundation. Step 2, practice, practice, practice with numericals. You have to build your speed and accuracy. Step 3, as you go, create a concise formula sheet for quick revision. And finally, the most important step of all, master the previous year questions.
NEET loves to repeat concepts, and PYQs are your direct line into the examiner's mind.
And for those concepts that need a little help sticking in your brain, use mnemonics. A great one for Kepler's laws is EAT. E is for the elliptical orbits of the first law, A is for the equal area swept in equal times from the second law, and T is for the time period relationship, T squared is proportional to R cubed, of the third law. EAT. Simple, right?
Theory is great, but execution is what gets you the marks. So let's put our game plan into action right now. We are going to walk through a real previous year question from NEET step by step so you can see exactly how this whole process works when you're under pressure. This is a classic NEET question. Why? Because it's not just about plugging numbers into a formula. It tests your conceptual understanding of relationships and your ability to handle percentage changes, which is a very common question type. So how do we tackle this? We follow a clear method. First, you recall the basic formula for G. Easy. Second, and this is the most important part, you identify the relationship. G is proportional to 1 over R squared. Third, and this is the shortcut that saves you so much time, for small percentage changes like this, you can bring the power down as a multiplier. That means the percentage change in G is approximately minus 2 times the percentage change in R. So since the radius shrinks by 1%, its change is minus 1%. Now, let's plug that into our shortcut. Minus 2 times minus 1% gives us a positive 2%. So the key takeaway? G increases by 2%. It's a perfect example of how knowing the underlying relationship lets you solve the problem in just a few seconds. All right, let's wrap this up with your final briefing. Gravitation is a predictable source of 8 to 12 marks. Don't leave them on the table. Focus your energy on those high-yield topics we covered. Be hyper-aware of the common traps we just disarmed, and execute your 4-step game plan with a special focus on those PYQs. You now have the complete playbook to conquer this chapter. You have the concepts, you know the traps, you have the strategy, and you know how to apply it. The only question left is, are you ready to go out there and claim your marks? Go get them.